Today, we're going to talk about a common mistake in TIG welding, one that affects both the appearance and the strength of the weld: porosity, or the formation of pores in the weld. This defect is common in stainless steel, aluminum, and even regular steel, for example. But the good news is, porosity is an entirely preventable defect. In this video, I'll show you step by step why porosity occurs, how to prevent it, and how to fix it if it does happen. The first step to fixing porosity is understanding what causes it. Porosity occurs when gas gets trapped inside the molten weld pool. As it cools down, these gases can't escape and remain as tiny small holes within the weld. So, where do these gases actually come from? The most common causes are a dirty metal surface, rust, oil, and dust. Insufficient gas shielding, the presence of moisture and humidity, the formation of an oxide layer, a dirty tungsten tip, or a dirty filler rod can all cause problems. In short, the issue usually stems from two main things: overall cleanliness and proper gas shielding. 60% of porosity is caused by a dirty metal. Before you start welding, if there's any visible rust, use a quality rust remover or a sturdy wire brush. Clean oily or greasy surfaces thoroughly with acetone. Blow off dusty surfaces with a compressed air gun. Even a fingerprint can trap gas. Leave the surface completely clean. If you're welding aluminum, be extra careful and thoroughly clean it. The oxide layer on its surface will trap gas inside the weld. For this, use a dedicated stainless steel brush just for aluminum. Don't use this brush on any other metal. Gas shielding is the heart of TIG welding. If there's a problem with your gas, porosity is inevitable. Here's what you need to carefully check. Are there any leaks coming from the regulator? Are the hose connections properly and securely tight? Is the gas passage on the torch clean? Is the nozzle cracked or clogged? The correct flow rate is 20 to 30 cubic feet per hour, which is about 10 to 15 liters per minute. If the gas flow is too low, the weld pool will fill with oxygen. If it's too high, you'll get turbulence, which also pulls in air. Use 100% pure argon. A mixed gas will often cause porosity in TIG welding. A dirty or improperly sharpened tungsten electrode can't create a stable arc. If the arc isn't stable, the gas shielding can't provide full coverage. Pay attention to this. Carefully sharpen the tungsten lengthwise along its length. If the tip turns black, you must resharpen it. There shouldn't be any dust, spatter, or blockages inside the nozzle. Choose the appropriate nozzle size for the job for optimal performance. The right tungsten results in a stable arc, which results in absolutely no porosity. Filler rods are the part most welders neglect. Filler rods absorb moisture, soak up oil from the environment, collect dust, and pick up oil and dirt from your hands. This contamination introduces hydrogen into the weld pool. Hydrogen is one of the primary causes of porosity in welds. Store your filler rods in a sealed container. Wipe with a clean cloth before welding. Even a little dirt can ruin the entire weld. Excessive heat or a longer arc distance can cause the weld pool to take in more gas from the surrounding air. The ideal arc distance is 1/8 of an inch, which is approximately 3 millimeters. Increase your control of the heat with the pedal and carefully make sure the pool always remains stable and calm. Overheating increases porosity. A smooth, calm bath equals a clean spring. Let's say a pore has formed. What are we going to do? Grind or cut the porous area completely and thoroughly. Ensure that you clean the entire porous part, not just the surface. Wipe the surface again with acetone. Carefully recheck the nozzle, tungsten, or gas settings again. Weld the same area again, making sure to do it carefully and thoroughly. Welding over a porous weld is definitely not the correct solution. The pore continues to remain inside. The only solution is to thoroughly clean, carefully fix, and re-weld the affected area. This is our guide to preventing and correcting porosity in TIG welding. If you find this video helpful, don't forget to like it and subscribe to the channel for more valuable welding tutorials. See you in our next video.